What's up guys, it's Novice here and I'm back with another video. I know it's been a little bit, but you know, sometimes life gets a little busy, but that's fine. Now today's video, we are going to focus on building out a password cracker. So in the previous video, I showed you guys how to actually obtain password hashes and then use Hashcat to crack them. But out of just curiosity and interest, I was like, can I build a simpler password cracker so that I can kind of know the underlying mechanisms of how it works and why it works. And for me, it's kind of helpful in a situation where for some reason you're unable to install a tool such as Hashcat. If that's the case, you can kind of know how you can build one out. But that's kind of my justification for wanting to build a password cracker. So I'll actually break this video up into parts because for this password cracker, I'm going to actually be using 4 different hashing methods. Yeah, 4 different hashing methods. So the first 2 are going to be MD4 and NTLM. The next one, I think, is SHA-1, and then finally I'm gonna round it out by doing MD5. So in today's video, I'm actually gonna go over how to build out an object or a class and an object to extract the MD4 hashes and NTLM hashes from a password. So with that intro, we are now just gonna go ahead and hop right into it. So this video is gonna be very code intensive, so be prepared. Okay, so on my screen right now, you should be able to see Visual Studio Code. So with that being said, I'll kind of explain how to actually go through and do MD4 hashing, because that's kind of going to be the brunks, or that's going to be what we're aiming for with this first class. So let me see, if we do file, let's do a new file, do a Python. So like I said, the goal of this file is to mimic what MD4 does. For that, we need to import this struct library. Let's keep that in mind. Now, like I said, I want to build out a class. For me, this is honestly something I want to do because I want to get more used to this, or more used to building classes. I feel like I have a deficiency in that, so I'm trying to get a little better, doing it while showing you guys, so on and so forth. So let me see, that is going to be our class. Then we're gonna have def in it. Now this will just initialize the class itself, and what I want is for it to take a password, as one of its arguments or parameters. Now, kind of gonna break down how to do MD4 hashing before actually starting this, because that is just gonna help us out here so that we understand what is going on. Okay, so with MD4 hashing, it can kind of be broken down in this way. So first, you pretty much receive your password. In this case, these passwords are then converted into ASCII. Another way to think about ASCII, especially when we go into the Python, is going to be UTF-8. Now in this form, they're pretty much turned into ASCII characters, so hexadecimal, which can then be broken down into bytes for later processing. Now from there, after they're broken down into those bytes, bits, same difference. From there, you're gonna want to append an extra single byte on there. Now when you append this byte onto the end, you want to do it in the simplest sense. It will be 1 followed by 7 zeros. That will be the complete byte. Now after that is complete, what you want to do is append bytes of just, in this case it's kind of just padding of 0 bytes until the length of the message is equal to 448 modulus 512. Now the reason we're doing that is because for MD4 to work, it must have 64 bytes, but we kind of need it to be at 56 bytes before appending the length of the original message onto the end of it. Now once that length is appended on in an 8 byte format, then you're gonna have the 64 byte. You're gonna have the complete 64 bytes that you're actually looking for. Now, after this, you're gonna kind of want to break down your message into blocks of 64. MD4 only works in this way. So if it's longer than that, say for instance, instead of being 64 bits, it's 128 bits. I said bits, bytes. It's going to be split down the middle so that you have two different pairs of 64 bytes. 64 byte length words that you use going forward. Actually, this might be easier to show than to explain, because me explaining it, I'm confusing myself. So probably gonna cut this part out. Okay, so from here we're gonna kind of explain how MD4 works, why it works. Yeah, essentially we're gonna explain how MD4 works, because from there you're gonna understand why we're building out certain functions for this class and how they all work with each other. So first up, like I said, this class is going to end up grabbing a password. So once it grabs that password, we're just gonna set that password. Now we don't want to encode it as this is suggesting for UTF-16LE, because that is actually going to be the format we would need for NTLM. What we're trying to do is build this out for MD4, and as such, we're just going to use it as password right now, but in the future, we're going to encode it as UTF-8, which is essentially ASCII. So we're just going to leave this like this. Now next up, we're actually going to make a function for the conversion. Okay, like I said, all we're going to do is place this to be UTF-8, and this is going to work with MD4 hash. It needs to be input in this format, or else it will not give you the right hash output. Now from there, what we want to do is actually append a 1 at the end of the encoded message. So what does that mean? So let me type this out and then I'll explain it afterwards, because I think it's going to make more sense in that way. And then from here, we're essentially going to take what is returned from the UTF conversion and then have it added. Let me see. Oh yeah, just like this. Well, not like this actually. So what we're gonna do, I believe it will be 8. Now, what this is doing is adding a byte, well, appending a 1 to the end of it, but in byte format. So essentially, in hexadecimal, 8 is written as 1000 in bit format. So essentially this puts 1000 followed by that extra 0, so 0000 onto the end of what we already converted here, making it so that that length is now a part of the conversion, or that length is now a part of the modified encoded password. From there, what we're going to do is we are going to add the padding. Now for the padding, we're essentially going to, let me type it out before I explain it, before it makes it look confusing. So essentially what this function is looking to do is that after you've added the 1 extra byte at the end of the already converted message, this is going to pad out the rest of the password. So this is necessary because for MD4 to work properly, you must actually have 64 bytes of information. Now what this essentially is doing is making it so that you have 56 bytes of information. Now it seems like I'm contradicting myself, but I'm not, because the 56 bytes is what's needed first, and then after that we're going to actually have to add one more thing to the end of this, and that will be the length. So okay, I'll take this now. Length appending, right? Okay, I'll follow what this is saying because it should do essentially what I'm trying to do right now. So what this is doing is that it is taking our password that has been passed in through the the UTF conversion, then append byte, then padding, storing that into byte data. From there, it's actually calculating the bit length from the length of the UTF conversion, which is this password right here, this encoded password right here, takes that length and kind of just, in case there's anything extra at the end, I forget the name of it, but kind of ignores the rest of it, except I believe this is, I don't want to count it all. I'm going to assume it's 56 bytes or 64, but that's what that does there. And then from there, after the bit length is actually converted, it is added to the very end of byte data. So when the length is actually appended to the end of this, it is turned into, sorry, words are failing me right now. It's turned into a byte. So say for instance, my password has 5 letters in it. Once it's turned into a byte, it's actually going to return, it's actually going to have 40 bits on there. Am I doing this right? 540. Yes, okay. So say my password has 5 characters in it. Each character in the password is actually representing an entire byte. Now, since there's 5 of them, 5 times 8, which is the amount of bits within a byte, give you a number of 40. Now, the number 40 is then turned into a byte format. So, I can't remember the number off the top of my head, but it's turned into that number. And then if that length does not equal an 8-bit number, we pad the rest out with zeros. So that's essentially what this is doing here. And then once that happens, it adds that or appends that to the end of our byte data, which has been transformed by turning it into UTF first, UTF-8, adding that extra bit, and then from there, padding on extra zeros, and then finally, now we add the length on top of it. Now that leaves us with 64 byte block. Hopefully you guys are following so far. Now, like I said, it's necessary that we have 64 byte blocks because that is the only way that something like this will work, especially with MD4, because this hash requires that. Now from there, we're going to create 64 byte underscore blocks. Enter. Yes. Okay. Now a quick breakdown of what this is doing. Actually, let me change this into something. Just makes it easier on myself. We're just gonna return. That is what I want to see. Okay. It does the same thing, but I just like how it looks this way a little bit better. So what this is doing is breaking down this password into 64 byte blocks. Now, if we were to think about how this could be important, MD4 isn't just used for passwords, it's also used for hashing in general, which is used to validate integrity. So say if you had a very large amount of words, say a book that needed a hash, this still needs to be broken down into the length of the hash, which is blanking on that right now, but it needs to shorten itself to the length of the MD4 hash. Now, when we do that, that won't create a clean 64 byte block. What it would do is create multiple, or a length that's longer than 64 bytes. Now, if that's the case, we have to then break up those blocks into 64 byte chunks, and then actually run each of those chunks through this MD4 function that I'm about to show you. And then from there, append all of them together at the end to, well, not append, I believe add all of them together at the end to get your final hash value. So now we're actually going to continue so that we can do so. Now this is where some things get important, because we're about to get into the rounds, if I can type, into the rounds of MD4. Now, to get started, MD4 actually starts off with these variables. I'm assuming computer already knows them, so I'll just get started with this. Now, with MD4, each block of 64 bytes goes through these rounds, and it starts off with this A, B, C, and D. After that, you're gonna have 16 rounds. You're gonna have 3 different sets of 16 rounds that happen to each block to transform them into a hash value. And then once that's done, if you have multiple blocks, like I said, they're added onto each other. And then if you only have a single block, you have your hash at the very end of those. In total, 48 rounds, because it's 3 sets of 16 rounds doing different functions. Now, if we were to get started, we initialize this. I'm just gonna create the for loop. Actually, let me do it like this. Blocks will actually be equal to this. Now we do for block in blocks. This is what is going to happen. And it looks like it's already kind of initializing what it's meant to do. So before that, I will actually go through and do one more thing. So I'll come up here and create certain functions that need to be executed in each of the rounds. So I'm gonna call this if I can type right, I'll call it first function. And boom. So this is gonna be the very first function we use. The second function we use. Third function we use. Now, what these functions are used for is in each of the sets of rounds. So in the very first round, it actually goes through using X and Y and Z, and then returns these values here. Now, the reason I'm using X and Y, in the actual functions themselves, these are replaced with either A, B, C, or D from here, but as they're transformed through the function that we're about to go through. It might be easier to see that than hear what I'm saying about it. So let me come down here and actually get started on creating this for loop. Oh, actually, one last thing. In most of the rounds, after the fact, we will have to do a rotation. And this is how we'll do it. So what this is doing is shifting the bits left by a certain amount, and that amount is actually going to be determined in the specific function or round that we're doing. So let's come down here and actually get started. So for blocking blocks, what we're gonna need, okay, so I'm actually gonna tab this out because it looks like it's figured out what I'm trying to do, and then I'll go through and explain what's going on in each round. Boom. Okay, so this has pretty much walked us through each of the rounds, but let me break down what's happening here. So in this list, like I said, there's 64 byte blocks that are in use. For each of those 64 byte blocks, we're actually going to break it down into a list. A list of 16 different 32-byte blocks. 32-bit blocks, which means 4-byte blocks. Once those are actually broken up into those blocks, they actually get used within some of these, well, within each of these functions to actually get an answer. So essentially imagine you have something that's 64 bytes long. Now you see that it's 64 bytes long. You split up the bytes by groups of 4, giving you 16 groups of 4 bytes. Now each of those 4 bytes are then put into these rounds here to give an answer, and those answers are used to continue in the rounds and then actually output a solution. Now let's go through each of these and hopefully it'll make more sense. So first we kind of set it so that we have the original values of A, B, C, and D. Now, as that continues, come down here. Now, the S's and D's list are actually used as in the left rotate function. So these are the number of times that they're going to be moved, shifted to the left. So for instance, let's try to go through a Mach 1 and see if we get this. So for I in range of 16, so this is a function that goes from 0 to 16, essentially. So it calculates, let me try to find the best way to explain this. So what this is essentially doing is that it's going through and trying to determine what part of the, I guess, what round you're on, to determine how many times to shift to the left and which letters to be used in the shifting. Well, rewind. What this is trying to do is that it's determining the round that you're on. The round that you're on determines which or how many times a bit is rotated to the left. Not only that, using the I, it pulls out the information within, what's the best way to say it? It gets each of the 16 4-byte blocks within the 64 blocks and uses it in conjunction with this function. And then what that does is that it puts the function into a specific letter. Now, what this does, maybe I'll get a graph and show you guys. Okay, so what the first function does is the following. It stores new information within each variable depending on what part of the round that it's on. So on round 0, round 4, round 8, 12, these ones will store a new value within A. The value within A is based on the original value of A, as well as the output from the function, the first function, with the actual arguments being B, C, and D. And then finally we have a bitwise addition with A, the result of that first function, and then the actual 4-byte word that is within that 64-byte word that is in use at the time, based on the placement, based on the round that we're on. From there, once these are all added onto each other, the bits are then shifted, also determined by the round that is on, by either 3, 7, 11, or 19. From there, there's actually a rotation between our variables. So whatever was in A, now the solution in this case is now put into B. Whatever is in B is actually shifted to C. Whatever is in C is shifted into D, and whatever was in D is shifted into A. Now, this happens not only with the A variable, but it actually continues on with D, C, and B as well, which is why each of these have their own different else if function, because this is all determined on the round that it's used in. So keep that in mind. Now the same thing is also done in in round 2. However, the difference is that the way that the bytes within the 64-byte, the way that the 4-byte word within the 64-byte word is chosen is not in order of 0 through 15 in this case. It's now going to be based on the number that you're currently on, well, the modulus of the number that you're currently on divided by 4 times then 4 plus the whole number of that number that you're currently on divided by 4. So in a roundabout way, it's still gonna go through each of the 4-byte words within the larger 64-byte word, but the order is now changed, so it's not going from the first 4-byte word in the 64-byte word in order to the second 4-byte word, third 4-byte word, fourth 4-byte word, and so on and so forth. It's now actually being chosen through this expression here. And then we also have the order in round 3. Now, the order in round 3, it's already preset. So when K is used, it is based on this order sheet. So for instance, when you have 0 in the range, so I is equal to 0 in this case, the order is actually going to be equal to 0. However, when I is equal to 1, the order is actually going to be 8. Therefore, the 8 4-byte word in the 64-byte word would be what is being used here, plus this extra constant here, plus the results of the third function, which, if I'm not wrong, it's XORing, in this case B, C, and D, and then finally you add it to the A or whatever variable that you're currently using. It is quite the process. Hopefully I was able to explain it well. If I wasn't, please let me know, and let me know also if the visual of the actual code helps you to understand it better. If not, like I said, I'll also add the hash for algorithm on the screen as well, because honestly, to me, it is so much easier to read. Now, after each round, after all 48 rounds have been completed, you then take the original value for A and add it to the current value of A. Now the current value of A is the A that it just went through every transformation, being switched from A, B, C, D, and back to A, going through each function, having constants added to it, having other variables added to it. That is that A. The original A is actually going to be this A, this B, this C, and this D. So you're gonna add all of those together, and you're gonna do the same for each of the following variables. Now, once you're done there, you're essentially going to grab all 4 of these bytes, all 4 of these words, which are 4 bytes long. Yeah, sorry, the bits, they're confusing my brain right now. But you're gonna take all 4 of these 4-byte words and combine them together, which is accomplished by the struct.pack. Yeah, so each of the 4-byte words are combined into, well, not combined. When I say combined, I don't mean that they're added with each other, I mean that they're appended to each other. So say for instance, we're just gonna use regular numbers. Say A is equal to 1, B is equal to 2, C is equal to 3, and D is equal to 4. What we're gonna do is put that together to make 1, 2, 3, 4. So 1,234. And that is essentially what this return function does. Whew, it was long to explain that, but that is what the main chunk of the MD4 hash actually is. And then from there, you're actually able, or what I like to do is create a final function that pretty much lets you know this is the hash itself. So what I'm gonna do, definition, let's call it hash. Then I'm gonna do self. And then in this case, we're not gonna want it in hex because it should be output that way already. Whew. Hopefully you guys enjoyed that as much as I did. So now what we're gonna do, we're gonna save this. Going to name it MD4. Save. And now what we're gonna do is that we are actually going to test this out. So we're gonna do new file. I'm going to create a new file, Python file, and we're going to call this test.py, but we'll do that later. And what we're going to do is import MD4. Now importing MD4 imports the class that we made here so that we can actually use it within this file as well. And since they're both located in the same folder, that's all that I have to do. Now, what I'm going to do, I'm going to create something, create a variable. I'm just going to call it convert, and then equal, and now we're going to do MD4. And in this case, it's not actually going to be new because the function that we named this as, or the class that we named it as, is MD4. And then from there, we actually have to input now a password. So the password I'll choose is hello. No, just hello. Just hello. And then finally, we're actually going to call the function that completes this whole process, which is hash. Now from there, we're gonna want to print convert to see that this actually went through. First, let me save this. I'm gonna save it as test. Give that a save. All right, and now we're gonna play this. I am forgetting something. .hex. Okay, let's save this again and give it another try. Because what this does, it does output the information the same, but it adds the actual hex, like \x, which is usually the telltale sign that you're something's in hexadecimal. It leaves that in here and it looks disgusting. So, boom. And now it's output properly. So, let me see. The best way for us to see if this actually worked would be to compare it with something different. Like I said, I went and got the hash algorithm here. I'll actually add this to the video later. But let me see, actually. MD4 hash generator. And now we're actually going to put in the same thing. So we'll put in hello and then generate the MD4 hash. And as you can see, we get the exact same thing that we get for, well, we get the exact same thing that we have here. Here we can compare it. 86437, it's the very beginning, the very end, 0362EE27. So the reason that this is important in building a password cracker is because with the password cracker, you're not actually comparing the passwords, because what most databases store is not the password in password format, but the password in the hash format. Now with hashes, you can't actually go back and reverse engineer it to actually pull the password. What you have to do is essentially assume a word that you think is the password, push it through a hash function like we just created, and then determine if that hash matches the hash that you got from whatever system that you're trying to grab the password for. If those hashes match, then you can determine that the word, in this case, since our hashes match, the password would have been hello in this case. And then from there you have the password and you can do whatever you need to do with that. So essentially we're building out these functions because we want to build those hashes from the word list that we're given or from a password that we're given, so that we can then continue to crack the password. Now for that, in this case, we can build a longer password cracker, but I only want to start with 4 different of the hashing algorithms. So we now went through MD4. Now we're also going to go through NTLM. Now NTLM is how Windows, or one of the ways that Windows stores its hashes. Now we're going to go through that because it is eerily similar to how MD4 does it. There's just one slight change, one simple change. So we're gonna create a new file, and then I am not even going to change anything. You guys are literally watching my screen as well. We're going to copy and paste everything here. Now, the one thing we'll have to change, it's going to be two things because I have to change the class to NTLM as well. But the one big thing we have to change is actually just how this is encoded. So you saw prior that when we first started, it was trying to get us to change the encoding to UTF-16LE, which is just 16 in Little Endian. So what this is doing is actually that it's grabbing and encoding the password we put in a different format. However, it's still using the MD4 hashing function to go through and make the changes that are necessary. So if we go ahead and save this, make this NTLM, save. We do import NTLM. Now we're going to do the same thing, but we're going to use instead NTLM. Try to save. Now what is going to be exported are two different hash values. One of course being MD4 and the other being NTLM. So when we do so, you should be able to see the differences between the two, but let's just go ahead and run it. Oh, did I do something wrong? Oh, I forgot to change this to NTLM. That is on me. I was like, what do you mean there's no NTLM? I know I did NTLM. All right, now we're gonna run it. Now we get out this hash. Now I'm gonna pull up an online NTLM hash generator so that we can actually see if that is the correct hash. So NTLM hash generator. I'm doing this on a different screen, but I will show it to you guys soon. So if we come here now and we just type in hello, because I think that is what I used to calculate NTLM hash, you get this value here. If you copy this, minimize this, place it here, you can see that it is the exact same as this password hash here as well. So we have now created not only the MD4 function, we've created the NTLM. And as I previously stated, these are important for password cracker because we need a way to compare not the password, but their hashes to the password or password list that we got from either an attack or pen testing, simulation. I forget what they're called. When you get a password from a system that you've been trying to crack, these hashing functions will be necessary because, as previously stated, it is the hash that we're looking for because that's how the system is storing that information. They're not going to store the information in plain text. If they do, that is just awful. Good for you if you're cracking it or pen testing it, but very awful practice in general. Most of the time it will be in hash format. Now I know that was a little long, but that is it for today's video on creating a password cracker. In the next part, we're going to put everything together so that in our password cracker, people have the option to choose what type of hash they're trying to crack. And if they have that option, for us, they're going to be able to crack MD4 functions, NTLM functions, MD5 functions, and finally SHA-1 functions. So if those hashes are ever grabbed in any type of penetration test, you can then try to get the password through brute force, well, through a dictionary attack, or even brute forcing if you want to, but you'll be able to do it through those means in our password cracker. Now that is the end of today's video. Please let me know if you guys like this way of me showing information, because I was debating between doing this or actually explaining it first and then showing you, but for me it's easier to see it in code. It helps me to understand what's actually happening, because when people explain it, it's just like, what are you talking about, bro? So please let me know if that is helpful, or if you guys would want an explanation beforehand so that I can actually get better at catering to what you guys are looking for and get better at explaining things in different ways. But with that, that is the end. Hope you guys enjoyed the video. If there was something about the video that you didn't like, please let me know. I'm trying to fix it, get better. And finally, if you want to subscribe, you support what I'm doing, go ahead and hit that subscribe button. And yeah, that's it for me. Novice out. Peace.